Okay, so this is for the PDQ number 2. So this problem, first we're going to label the acid and base. So we're going to have, this is going to be the base because of the negative charge, while this molecule is going to be the acid. So bases always take the hydrogen, it's going to take the hydrogen off of this nitrogen, while the bond from the hydrogen and nitrogen is going to go and make a lone pair. This acid is going to do that because the acid is going to dissociate its protons. So we're going to have Cl, S is going to have an H to it. It's going to have a double bond still. It's going to have lone pair plus F. It's going to have an N. It's going to have one H, and it's going to have two lone pairs. It's going to be a negative charge now. So these are just the two new molecules that we have, and so once the other side of the reaction. So we know that because of this base with the sulfur, this is going to be the conjugate acid, and this is going to be the conjugate base. Then we know, sorry, I forgot these lone pairs. Then we know that we are trying to figure out which one is going to be the strong acid and the weak acid. And how we do that is we're going to look at the bases. So, and how we determine that is through REO. So first we're going to look at atoms of the A of REO. So we have the nitrogen of this base and the sulfur of this base. So we know that once we look at REO, we want to look at the periodic table of electronegativity. So we look at the periodic table, we know that nitrogen, and then we have sulfur. Well, sulfur's size is a bit bigger. We can't really talk about electronegativity as much because they're not in the same row, but the size, they are, sulfur is a lot bigger, so it's going to be able to distribute it more, making sulfur, this base, more stable, making this a weak base, making its acid, its conjugate acid of that base, a strong acid. While we know that this base is going to be a little bit stronger than this base, and this is going to be a weak acid. So we're going to have two weaks, a weak base and a weak acid, going against making to form a strong acid and a strong base. Now we're going to see which acid is expected to have a higher pKa value out of these two acids. So since we know that a strong acid, it's going to have a lower pKa, meaning that it should be around closer to 0 or a negative because it's a strong acid, while a weaker acid should have a higher pKa value. So this would have the higher pKa value, this ion. And then the equilibrium, we know that the equilibrium, because of a strong acid, is more readily to dissociate or more readily to give up its hydrogens. We know that the equilibrium will shift to the left. And we also know that the two species that present in the highest concentration are going to be these two species because the equilibrium is going to shift to the left, causing more of these to form.